So if you're watching this video, this is the one that shows you conceptually like how to make a Flippy Do and what it's actually all about. But as you notice there, I have it pulled up. That is the template that is accessible on code.org. So like if you're at home and you ask your parents and you want to have them print out a Flippy Do for you, just make sure that you print it out, and then once you print it out, like it says, cut along those dotted lines, because that actually makes it a little bit easier for the whole concept of this Flippy Do. And the reason for a Flippy Do is it breaks it down to show you collectively of how you can actually uh, show binary a little bit easier and everything. Because the important part of this is it sections it off in such a way that you have basically the breakdown of a byte. A byte, of course, like we discussed, a byte is 8 bits, but it's in machine language or computer language. Uh, the way that we compress the data and everything, and using binary in such a way that um, each byte is basically your one or your zero. Collectively, you usually put it in patterns of 3, which is an octal, or patterns of 4, which is a hexadecimal number, or then we set up the byte itself, which is the 8 bits, and we actually put it in a hex pair. So you have 4 bits that make up one hexadecimal number, and the other 4 bits make up the other hexadecimal number. So you can actually have a hex pair, which is 2 hexadecimal numbers. And a lot of times when you're actually writing assembly language, you write it in hex pairs to make sure that it's a little bit easier to write out your code and everything, so you can actually go through that process. But a little more on that. More importantly, let's go back to this Flippy Do and kind of look at it. So just remember the Flippy Do on the bottom, as you want to fill out the information. Here are all your zeros on the bottom there. And then for your flip parts, you have ones, okay? And then up here at the top, and however this makes it a little bit easier for you to process, but up here at the top, just remember you start out at 2 to the 0 power, which this first place gives you a value of 1. 2 to the first power, so this second place gives you a value of 2. 2 to the second power, this value gives you 4. 2 to the third power, this spot gives you value of 8. 2 to the fourth power, this spot gives you 16. 2 to the fifth power, this spot gives you 32. 2 to the sixth power, this spot gives you 64. And 2 to the seventh power, this spot gives you 128, right? So now, this next part of it, obviously, is going to use a pencil, so you can always erase Makes it a little bit easier as you go through the process, so you don't have to constantly keep on making new Flippy Doos and pin everything. So let's go through and figure out let's come up with a number. Let's do 153. We're going to figure out how it actually shows up in binary, right? So using the Flippy Do, if we want to convert the decimal number 153 to binary, we start at this side to make it a little bit easier as we go through, so we can actually get the proper binary number, right? So since 153 is a pretty big number, we go through first of all, can we use 128? Yeah, we definitely can. So we're going to use 128. We'll subtract it from 153, right? And that gives us 25 left over, but we definitely got to use a 1 right here in order to so we can use that 128, and then we're left with 25. So since we're left with 25, can we use a 64? No, we can't use a 64, so we'll keep that at 0. We take the 25 here. Can we use a 32? No, we can't use 32 because it's too big. So we go to the next spot. Can we use a 16? Yeah, we can use a 16 because 25 is what we have left. So take 25, subtract 16. That gives us 9 left, but we do have to use a 25, right? So that gives us 1, 0, 0, 1 so far, and we have 9 left. So 9, can we use an 8? Yep, we can use an 8. So we put, we take that 9, we subtract 8. That leaves us with 1, but we definitely have to use an 8. So we have a 1 here. Can't use 4, can't use a 2, but we can definitely use a 1. So 1, 1, that leaves us with our 0, but we definitely got to use the 1. So in doing the conversion for 153 in decimal, written in a binary number that is 1001, 1001. And that's kind of the process of how we actually utilize the Flippy Do, going through, and how we can actually do a conversion using the Flippy Do.